Students online, all of you all, very good afternoon, everyone. Very good afternoon. Welcome to today's class, your second unit 1 class, isn't it? Okay, last week we couldn't have class. It was a holiday. This is your second unit 1 class. Okay, so all of you all in topic 1, part 1. Today also the whole day will be going in topic 1, part 1. Okay, there's a lot to go through it, a few videos to show you all in it. Everybody, shall we first recall what we are talking about? We are talking about computer hardware, isn't it? We are talking about the physical components that make up a computer. Okay, everybody, in topic 1. Last week we started off with the physical components that make up a computer, and I broke it down into 3 categories. Remember those 3 categories? You had your, what are 3 categories of computer hardware? You had your input devices, you had your storage or processing devices, and then you had your output devices. These were the 3 categories of computer hardware. Then guys, we then spoke about something else, features and functions of a device. Okay, you all remember what a feature is, right? Everyone, a feature is a part of your device, your touch screen, your keyboard, your webcam, your microphone. These are features of your device. Functions are what your device can do for you, or how can you use your device. That is what we call functions. Features are what does it have, function is what can you do with it. What does it offer you? How can it be used? Those are functions. Under functions, guys, do you all remember we went through all these? Okay, we went through portability, we went through the characteristics of portability, we went through performance. Okay, let me just randomly pick something. We'll start with portability. What contributes towards portability? Louder. The size of the device, definitely. How big is the device? Next. The battery life of the device. Do you need to regularly charge it, or does it need to be connected to a live electricity supply, or does it have a rechargeable battery? Give me one more. I didn't get you. Durability. Durability is also one. Weight is also another one, isn't it? These are factors that contribute towards your portability. Okay. If I were to pick, for example, connectivity, what were your options? You had wireless and wired. Under wireless, just give me 3 options under wireless. You had Wi-Fi, Bluetooth, louder, NFC. Very nice. Under wired, we didn't go into the details. We just spoke about it, just the name of it only. USB, Ethernet, HDMI. Excellent. Okay. Then guys, when we come to security features, what would we have? You would have passwords, biometrics. Now these are all physical unauthorized access. Now for unauthorized access via a network, what are your security features? Firewall, okay, or encryption. Everybody okay with it? Password and biometrics are for physical unauthorized access, but encryption and firewall are for unauthorized access through networks. Then guys, we then spoke about something else. 1 second. Can you all see the next heading? Features that affect the design and use of a device. We spoke about GPS. GPS will not affect the design of your device because the GPS module is extremely very small, like a battery size, isn't it? So the design is not going to be affected, but how you use it, does it change? When a device has GPS included, the way you use it is going to change. Agree? Then guys, we spoke about biometrics. Biometrics also, it doesn't take up a lot of space, but you need to consider where you're going to place it. Some devices, they build the biometrics on the display itself. Some build it next to the volume button. Some build it behind the device. Everybody okay with this? And when you put biometrics, security of the device goes up. But your drawback is, what is your drawback? The battery life might go down. Your battery life is going to go down. Also purchasing price. The price of your device is going to go up, isn't it? Then we spoke about touchscreen and we came and stopped at touchscreens. Touchscreens make your device really, you get rid of the keyboard, you get rid of the mouse, everything is built into one device, which we call, your device becomes very portable. Another word would be compact. Your device becomes compact. Everything is built into one component. Everyone okay with this? Okay, so we now need to continue from sensors onwards. So can everyone move down to page number 12? Everybody, guys, girls, can we come down to page number 12? So our devices have a variety of sensors. Everybody okay with this? Our devices have a variety of sensors. Boys behind, Can you all read the bold words? Everyone, read the bold words below. So sensor is an input device. What does it do? It detects changes that are happening around you. Can everyone look at me? What are some of the changes a sensor could detect? Louder. Weather change. That's so many things. Pick some. Temperature. Okay. Distance. Distance is not measured using a sensor. Okay. It does calculations to get your distance. Agree? A sensor will send out signals. Boys, come on. All of you all. Distance is a result. A sensor does something and the result of it is distance. It doesn't measure distance as such. Okay. Motion. It can detect movement. Something else. It can detect light. Isn't it? It can detect what? For example, our phones have something called a proximity sensor. When you are on a call and you keep the phone on your ear, what happens? When you're on a call and you keep the phone on your ear, what happens to your display? Display goes off, right? Your display goes off. That's because your phone has a proximity sensor. It can detect if objects are close by. So if something is very close by, automatically display will go off. When you're on a phone call, guys, just keep your finger on the webcam on your selfie camera area. Just keep your finger there. What happens? The display would go off because it has detected that an object is very close to the speaker. So what does it do? It switches off the display so that nothing gets pressed accidentally. Okay, any other sensors? When you're viewing a video and if you rotate your phone, what happens? The display also rotates with it, right? Isn't it? When you're playing a car game, for example, if you slightly tilt the screen, the car moves to the right, moves to the left. It's using a sensor called what? Accelerometer. There's a sensor called accelerometer that can detect the movement of the device. Why would you need a light sensor in your phone? Why light sensor? Camera, okay, for the lens, okay. For the brightness, right? All of you all have enabled what? Adaptive brightness, right? Many of you all in your phones, you all have enabled adaptive brightness. What does that mean? Change the brightness based on the physical environment, right? Your brightness automatically adjusts based on your physical environment. Okay, give me another sensor. Temperature sensor for what in your phone? Your phone doesn't tell you the temperature using the temperature sensor. What is the temperature sensor in your phone for? Your phone gives you temperature by what? By connecting to a weather app, isn't it? Your phone gives you temperature by connecting to a weather app. Based on what the weather app tells you, it will tell you the temperature. But it still has a temperature sensor for what? For the battery, go on, to prevent overheating, right? To prevent overheating. So if it feels your phone is too warm, it will then tell you to shut it down. Okay? Any other sensor you can think of? Any other sensor? You can't charge, okay. Sends a message, okay. So you're saying maybe a water sensor there. It can detect liquids. When it detects a liquid, it'll give you a warning to immediately switch off the device. Okay, right. Awesome. Can you guys go through the examples I have given you all? Everyone go through the examples I have given you all. Light sensor, accelerometer, motion sensor. Okay. Temperature sensor. These are sensors that would be built into a device. The moment this is put into a device, the way you use the device is going to change. Also, guys, sensors are continuously running in the background. They are continuously detecting. So, obviously, what's your problem? Your battery life. Okay. These sensors bring about a lot of convenience for you, but then your battery life is going to be consumed because they're always detecting changes. Okay. All right. Awesome. Can we move on then, guys? I want to spend some time over here. Next, we talk about your device's memory. We have two types of memory. We have your RAM and your ROM. Everybody okay with it? Your RAM and your ROM. Can you guys read the meaning of those two words? Everybody? So ROM stands for read only memory and RAM stands for random access memory. Now guys, I want you to remember this. What does ROM do, guys? Can you all read the words here? Stores the startup instructions. ROM will instruct your computer on how to start up. Okay, how to load the date and time, where to load operating system from. Everybody okay with that? How to start your device? Instructions are stored where? stored in your ROM. What do we call those instructions? BIOS. Anyone knows what BIOS stands for? Basic Input Output System. Can we put that word over there? Can we put that word over there, guys? Startup instructions are what? BIOS. This is called BIOS. BIOS stands for Basic Input Output System. Okay. Then guys, you know what non-volatile means? It's non-volatile. Stores permanently. BIOS is permanently, forever there. You can't remove it, you can't change it, none of that. Okay. Stores permanently. Stores permanently. Then guys, can you all read RAM? Stores the data and instructions that are currently being processed. So guys, give me in simple words what that means. What does your RAM do? Holds programs running in the background. Programs running in the background, your RAM is holding it for you. Everybody okay? Can we note that down? Holds programs running in the background. Running in the background. I'll give you guys a quick example now. Alter tab. Everyone look here for a second. Alter tab. Can you see all these programs are open, everyone? Edge is open, WhatsApp is open, Zoom is open, File Explorer is open, Notepad is open, Word is open, YA Server is open, operating system is running. Who is holding all of them right now? It is my RAM who's holding all of them. So obviously, guys, if I increase the capacity of my RAM, what would my result be? Sorry? Performance. So be specific. How would performance get better? I can have more programs running in the background. Or like in terms of performance, you can say you can have a lot of programs running in the background without the computer crashing, slowing, lagging. Everyone okay with this? Right, you all understood that. Okay. Can you all read this paragraph then? The size of memory, especially RAM. Read it, guys. It's basically telling you when you have a tute, no, right? Can you come and take it? It's basically telling you when your RAM capacity is high, you can have lots of programs running in the background without the computer slowing down. Okay. Can everyone note that down? Come on, girls. Soon. Oh, boys, it has finished. I'll get you another one maybe next class. Okay. Everybody okay with this? Sounds good? Okay. Right. So guys, memory guys, what did you understand? RAM is volatile, which means now guys, all of y'all, if my laptop battery were to go dead right now, let's say it goes down all the way to 0. Okay. And my laptop shuts down. When I switch on my laptop, will it open up with all these programs? Girls, all of y'all, will my laptop, when I switch on my laptop, will all these programs be open in the background? Answer is no, because RAM is temporary, volatile, right? When the power is knocked off, everything on the RAM is lost. Okay, boys. So all this data will be gone. Once the power goes off, all this data is lost. Okay, but ROM on the other hand is non-volatile. Even when there is no power, it's still holding your data. Are we good? Everyone? Okay. Can you all read storage then? Storage is referring to something which we call secondary. Okay, secondary storage. So you can talk about, shall we put next to it? HDD, hard disk, pen drive, SSD, solid state drive. All these come as your storage. You permanently store data there. Data on your storage is never lost. It's long-term memory, we say. Or we simply say storage. Okay. Can you guys read the bold words, everyone? Bold words, please. It allows the device to retain. You know what retain means, boys? Retain means what? Keep it permanently. Until you choose to delete it, the data will remain there. Okay? Even when there is no power. Okay? So everybody, are we okay with this? Okay? What are we talking about? Features that affect the design and use of a device. Okay. Come on, boys. Come on. Okay. Features that affect the design and use of a device. Okay. Right. I'm going to move down, further down. Okay. Then guys, we come down to battery power. We would all love to have devices that can last for as long as possible. But without reading, tell me, if you go to increase your battery capacity, your problem is going to be, what's your problem going to be? It's not going to be portable because the weight is going to go up, isn't it? You guys have seen, you have 10,000 mAh power banks. They are quite light. 20,000, it gets a bit heavier. 30,000, even more heavier, isn't it? 40,000 onwards, it's like a brick. You can't even carry it around with you. Okay. So guys, as you increase your battery capacity, one is it's going to become less portable. Next is it's going to become dangerous also. Having so much of power in your pocket can cause problems, isn't it? It can cause overheating, burning, catching fire. Those problems also come up. Everybody okay with it? So we have a problem when the battery power is increased as well. Okay. Can you guys read the last paragraph? What do we normally use in batteries? We are normally using lithium powered batteries. Okay. So now developers are looking at using solid state batteries, which are much slimmer. Okay, chargers even faster. Okay, makes the device more powerful. Okay. Then guys, we have another one called miniaturization. And this is something that's heavily happening today, which is increase the performance and decrease the size of your device. Everybody okay with this? Isn't it already happening with your smartphones? Your smartphones are as equally as powerful as a desktop, isn't it? The desktop size is so big, your smartphone is so much more smaller. It has a single board only inside it, but inside that single board, the performance is really good. Everybody okay with this? That's what we call miniaturization. Okay, making the device smaller but maintaining the performance. Can you guys read what I have told over there? You're adding more transistors into a single board. What do we call that board? Integrated circuits. Transistors control the flow of signals. So you're increasing the number of transistors. So more signals can flow every second. Okay, right? So guys, we are looking for ways. Computer manufacturers are looking for ways to make the transistor even smaller so that they can put Manufacturers are looking for ways to make the transistors even smaller so that they can increase the number of transistors on a single board. The more transistors you put, the better the power, the better the performance. Everybody okay with this? So manufacturers are looking for ways to make the transistor even smaller so that they can put even more on a single board. Are we good? Keep reading it, guys. I have an example to show you all. Read it. Integrated circuits are used in devices called embedded systems. Anyone know what embedded stands for? It has only one task. Don't say one task. You can say it's built to carry out a specific function. Okay, everybody. A computer, it accepts input, it processes, it gives you output, but does a very specific function. Like what? A calculator. A calculator is a computer, but it only functions in calculations. Everybody okay with it? So your calculator is known as an embedded system or an embedded computer. It has a single board, it has input, it has processing, it has memory, it has output, but all it does is calculations. Everybody okay with this? Think about this projector. It is a computer, but all it does is projecting a laptop display onto a screen. That's all it does. So it's known as an embedded computer. Can we note down the definition, girls, all of you? I have also noted it down somewhere else. Later on, it's coming up. Okay. Carries out a specific function. The example I have given you all in your note is the smartwatch. Your smartwatch, guys, it is an embedded computer. Okay. It carries out a very specific function. Okay. It is used to keep track of date time and it also tracks your physical activity here. Okay. Then guys, can you all read the third paragraph? An integrated circuit, word by word, okay, allows the device to be very small. but gives it the same performance. It gives it a really good performance. An example is the Raspberry Pi. Everyone, this is as equal as a desktop computer, but look at its size. Okay, I'll keep skipping parts. Okay, so check this out. It's a single board, but see the amount of components you can connect to it. We are done with miniaturization also. Let's keep moving to the next one. Okay. Can you all read? No, hold on there. The last paragraph. Single board computers will not have the same level performance as a full size computer, but they can provide the same functionality. Okay, they can pretty much do almost everything that a full size desktop can do. Performance also arguable. There are, look at your smartphones, guys. Your smartphones are pretty powerful, isn't it? Almost as powerful as a desktop. Okay. Okay, let's move away from here then, guys. Let's move down to the next one, where we talk about your processor. So guys, over here, we will have to take down some notes over here. Everyone. So every computer follows the IPO cycle. Now, what was the IPO cycle? You give it input, and then your input is processed, and then output takes place. So I need to explain to you all what this processor does, how powerful your processor is. Everyone, you'll have a writing books with you all. Can everyone take your writing books? Okay, and note this down. Please maintain a writing book. I told it to you all last week also. Okay. Can you all note down the heading? Measuring the performance of a processor. Measuring the performance of a processor. Everyone got this down? Measuring the performance of a processor. Okay, boys behind can read from there. Can read from there. I want to come in front. You can read from there. Can, okay. Measuring the performance of a processor. So when it comes to measuring the performance of a processor, guys, we use a unit called hertz. Okay. So here we say the unit hertz. The unit hertz is used, HZ is used in measuring the performance of a processor. So guys, when I tell you 1 hertz, what does it mean? One hertz means your processor can execute 1 instruction every second. That is the meaning of 1 hertz. Now you guys know what execute means? The processor is in the middle of input and output now. So execute would mean what? Converting an input into output. Give me a better wording for it. Converting data into information, or converting an instruction into information. That's what you mean by executing. You gave an instruction, the processor obeyed it and did the needful. You call that an execution. Everybody okay with this? So can you guys note down what 1 hertz means? Okay. Every second, the processor can execute 1 instruction. This is what we mean by 1 hertz. But boys, our processors are so much more powerful than this. Okay, so if you go to measure in hertz, you're going to have a very long number. It's like measuring the weight of a lorry in grams, what's going to happen? You'll get a value, but the value is going to be very big, isn't it? So normally you measure the weight of a lorry in tons, isn't it? So you say the lorry weight is 1 ton. Okay, if you go to measure in grams, you're going to have a very long number. Okay, so similarly, when it comes to measuring the speed of a processor in a computer, we don't use hertz. Hertz will give us a very long number. It's not wrong, it's that your answer will be very long. So we convert it into a bigger unit. Okay, so everyone look here. If you put 1000 hertz, guys, everybody, 1000 hertz will give you 1 kilohertz. Are we okay with this? So look here, guys. 1000 hertz is equal to 1 kilo, capital K, hertz, capital H. And 1000 kilohertz is equal to 1 megahertz. And 1000 megahertz would give you 1 gigahertz. We stop here. Okay. Now, boys, girls, I have a question for y'all, guys. Convert 2000 hertz to kilohertz. Okay, boys, all of y'all. Very simple question over here. Convert 2000 hertz to kilohertz. While you are writing, can you answer this with me? Hertz to kilohertz. We are going from a big unit to a small unit, or from a small unit to a big unit? We are going from small to big, right? Hertz is smaller than kilohertz. Agree? We are going from small to big. So guys, now what do we do? 2000 hertz to kilohertz. What's the answer going to be? 2. How did you get 2? You divided by 1000, isn't it? So guys, what do we do here? 2000 hertz. You're going to a big unit now, so you must divide. Divide by how much? Divide by 1000. Okay, very nice. 2000 hertz divided by 1000 kilohertz. Okay, now all of y'all over here, you can simply see cut. And here you have 2 kilohertz. Everybody okay with this? No problem over here. Let's go the other way around now. Let's go the other way around. $2.5 million. Sorry. I made a mistake. I made a mistake. 2.5 megahertz. I want you all to give it to me in hertz. First tell me, are we going from big to small or small to big? Big to small. So we need to multiply now. You're going from megahertz to hertz. Big unit to small unit. Other way around, not divide, you multiply. Okay? Guys, in your exams, boys over there, in your exams, calculators are not allowed. So the examiner does not need the final answer. He will tell you, construct an expression, which means just show me your working. I don't need the final answer. So calculators not allowed. Don't bring it to your IT exam. Okay? So what do we do here? 2.5. We need to go to megahertz now. So we multiply by how much? Step by step. Don't give me the answer directly. Step by step. We first go down to 1000 watt. We are in mega. I need to get to hertz. Come to kilo first. First come to kilo. 1000 kilohertz. Then from here, where do we go? From here we go to hertz. Isn't it? You're confused. We are here right now. No? From megahertz, I came to kilohertz. Now from kilohertz, I'm going to go to hertz. Okay? So now what am I going to do? Multiply by 1000 hertz. You can keep your answer like this. Perfectly all right. Or if you want to, simplify it, go ahead and simplify it. You can say 2.5 multiplied by 10 to the power of. If you want 2.5 times 10 to the power of how many zeros? 3 zeros here, 3 zeros here. 10 to the power of 6 hertz. Everybody okay with this? Shahad, are you okay there? Okay. Right. Now let's take a real life example. Okay. Let's take a real life example. Many laptops you buy in today's world will be about 3 gigahertz. I want you to tell me the power of that in words. Now you know what 3 gigahertz means, but imagine you're going with a person who doesn't know about it. How do you explain this statement to them? Now RAM, you can tell them when they say 8 GB RAM, you can say, hold on. This means in the background, you can have 8 GB of data running in the background. You can explain that to them. They can understand it. But if they tell you the processor is 3 gigahertz, how do you explain this to them? So first convert it into, if you want to explain the statement of 3 gigahertz to a layman, how do you explain it? First convert gigahertz to, not megahertz, still difficult to explain now. Convert it into hertz, isn't it? If you have something in gigahertz, first bring it down to hertz. Then explaining becomes easy. So how do we do it? Everybody, 3 gigahertz. I have 3 gigahertz over here. I want to convert it into hertz. How do we do it? We are going from a big unit to a small unit, right? So you need to keep multiplying until you get there. So tell me guys, 3 gigahertz. What do we have below? Look at the table and tell me. Below gigahertz is megahertz. How much? 1000. You need to multiply by 1000. 1000 megahertz. Then where do we go? How much? 1000. Again 1000. 1000 kilohertz. Then where? Hertz. How much? 1000. 1000 hertz. So basically guys, you can keep your answer like this perfectly all right. Otherwise, 3, how many zeros? 3 zeros here, 3 zeros here, 3 zeros here. That's 9 zeros. 1, 2, 3, 1, 2, 3, 1, 2, 3 hertz. What's this number? 3 billion, right? 9 zeros means billion now. So tell me in words now. The power of this processor is every second it can execute 3 billion instructions. For your information, guys, your processors are more powerful than this. Okay, if I'm not mistaken, about 5 times more powerful than this. I'm going to show it to you all. Real life example I'll take and show you all. Okay, everyone, did you all understand this? 3 gigahertz means what? Every second, my processor can execute 3 billion instructions. But your processors are way more powerful than this, at least 5 times more powerful than this. Okay, coming up shortly here. Okay, right. So far, so good. Everyone okay with this? How to convert? Anyone wants me to repeat it? Guys online, anyone thinks I should repeat this? How did you get zeros? How did you convert? Anybody? You want me to? Because guys, part 2 heavily works on this, okay? So it's better you understand it here, then part 2 becomes easy for you. Nobody, boys over there, everyone? No need? Okay, then I believe you all and I'm moving forward, okay? Right. Guys online, all of your apologies on my device suddenly decided to carry out its update. So that's why we issued the break early. Right, we'll keep moving now. So everybody, we were talking about the power of your processor, the number of instructions it can carry out every second. Come on, sit properly. Okay, the number of instructions it can execute every second. And I told you your processor is much more powerful than this. So let's take a real life example and see. Okay, so all of y'all, all iPhones, guys, in today's world, they all have a hexa-core processor. So we'll take them as an example. You can see over here, iPhone 16 Pro, guys. Let me zoom into this. When I zoom into its specs, guys, can you come over here? If you'll come into a CPU, can you all see over here? Hexa-core processor. 2 cores are working at a speed of 4.05 and another 4 are working at a speed of 2.42. Everybody okay with this? Combine them all together, you get a very large number for the number of instructions they can execute every second. Okay, take it one step further. If you take the Samsung Note series, the Note 20 Ultra, for example, the Samsung Note series all use octa-core processors. So if you come over here, where is it? Octa-core. And here there are 8 cores. So how do they work? 2 are working at a speed of 2.73. All of you all. 2 are working at a speed of 2.5. Another 4 are working at a speed of 2. If you multiply them and add them all together, you get a massive number. Okay, I think it's about 17 billion or 20 billion instructions it can execute every second. That's its maximum performance. If you take the Pixel series, guys, look at the Pixel score. What do you call? It's using a Nona core processor. 9 cores are being used here. Okay, it's using 9 cores in order to execute your instructions. Okay, so everybody, now do you all understand what these cores mean? So why are we using cores? Why are we having multiple cores? What are we trying to do? Sorry? Very good. Minimize energy consumption, right? When multiple cores are working, the amount of heat produced is going to reduce. Then the fan doesn't have to work so hard. When the fan doesn't have to work so hard, energy consumption is going to go down. Everybody okay with this? You'll have a longer battery life. Okay, so the main purpose, of course, we want to execute things quickly. That's one thing. Another reason is we want the battery life to last for as long as possible. Everybody okay with this? So by having multiple cores, energy consumption will go down. Are we all good? Okay, so everybody, let's come back to our note now. Can you all read your note now and see if it matches with what I told you all? Okay, so guys, clock speed is your hertz. Clock speed is hertz. Can you all read that? Okay, so now you all know what a processor does. Boys over there, what's going on? Boys over there, what's going on? Okay, let's read this. I'll move in 1 minute. Can you all go through it on your own now? Okay, the clock speed is basically the speed. Okay, there's a clock speed. It basically means speed, number of hertz per second. A number of hertz means number of instructions per second. Okay, okay, all right, guys, girls, all of y'all, something interesting coming up now. Everybody, are we okay with processor? So now we have seen processor, we have seen the power of a processor, we know what a processor does. Okay, now guys, can you come down to something called RFID, radio frequency identification? It's a wireless connectivity method. Are we okay with this? So all of you all, in today's world, guys, RFID is being heavily used. Okay, I'm going to give you all some real life examples. where RFID is being used in today's world. Okay, can you guys first read that first paragraph for me? So radio frequency identification, radio waves are used to identify, is used in digital devices to wirelessly identify and track objects. Okay, all of you have you all heard of the AirTag? All of you have heard of AirTag, right? You can attach a AirTag to your luggage, to your suitcase, to your bag. Is it clear? And then from your smartphone, you can track where the tag is. Everybody okay with this? From your smartphone, you can now track where that tag is. So if you take the AirTag, guys, the AirTag is a classic example for radio frequency identification. Okay. Now, all of y'all, if you were to open up the AirTag, everybody, if you were to open up the AirTag, guys, can everyone look here? Let me give you all an example over here. Where's my folder? 1 second, please. Let me quickly find it. Can you all read? It involves, can you all read that part? It involves, I'll load this image up. So everybody, if you take an RFID tag like the AirTag, guys, it's quite a, it's a, what do you call, a bit of a big device. Okay, it fits into your palm. Okay, all of you all, if you were to open up this device, if you were to open it up, you would see a structure like this. You would see an antenna, you would see a microchip, you would also see a battery. If you were to open up the AirTag, guys, there would be an antenna, there would be a microchip, there would also be a battery there. Everybody okay with this? This microchip can contain some data. Okay, the user's name, a serial number, whatever data you want, you can store inside this microchip. So now, guys, I'm going to explain to you all how this is used in today's world. Okay, now all of y'all, example number 1. Have any of y'all seen a tag like this? Nobody? Come on, think and see. Where did you see? You saw one like this? No, nobody? You guys don't go out? You all don't go to restaurants? In restaurants, yeah. Burleys, okay? So all of you have been just here, right? So how do they, when you place an order, how do they inform you your order is ready? They give you this tag, right? Once your order is done, they give you this tag and they tell you when your order is ready, this tag will start beeping. Everybody okay with this? They give you this tag and you can go and sit anywhere. You can go to your table and sit. When your order is ready, this will start beeping. Now, how does this work? Now, let's say, for example, guys, this is the RFID tag. We'll say this is the RFID tag, okay? So when they create your order, they will, this RFID tag is attached to the computer. They will program the bill number into the RFID tag's microchip. Did you all hear what I told you? They will program your bill number. You placed an order now. Let's say your bill number is 26. 26 will be programmed into the microchip of this RFID tag. And then they give you the tag. Everybody okay with this? Now, when order number 26 is ready, on the computer, they will send an instruction saying order number 26 is ready. Everybody okay with this? Now, what will happen is we have an RFID reader and you have the tag. Everyone, are you following with me here? The cashier has the reader, you have the tag. Now, what does the cashier do? When she says order number 26 is ready, the reader, which is with the cashier, will send out radio signals. And those radio signals will be detected by your RFID tag. Is it clear? The cashier from the reader will send out signals for order number 26. Those signals will be received by your tag. How will it be received by your tag? Your tag has a what inside it? Your tag has a antenna inside it, right? Your tag has an antenna inside it. Everybody okay with this? So the antenna will receive those signals and inform the microchip. What will the microchip do? In Burleys, what happens when your order is ready? It starts beeping. It starts beeping, right? It starts ringing. So now you know your order is ready. The microchip will then send an instruction to the beeper to start beeping. Everybody okay with this? Then the beeper starts beeping. Okay. So guys, over here, the component that is missing is the battery. Okay. How do you think this LED light is flashing? How do you think the beeper is working? Because there is a battery inside it. Everybody okay with this? This is what we call an active RFID tag. What do we call this? Active RFID tag. Active means what? It has a built-in battery. If it has a built-in battery, don't you think its size is going to be a bit bigger? Its size will be slightly bigger. Don't you think it will be a bit heavier? isn't it? What do you think about its signal range? Since it is battery powered, don't you think it will have a longer range? It would have a pretty good range, isn't it? Okay, can you guys read your note now? Everybody read your note. So can you guys first come down to active RFID tags? Active RFID tags, they have their own battery, so they can always send out signals. They have a longer range. Where do we use them? In vehicle tracking, in toll systems, and large asset monitoring. Like, for example, large asset as in, for example, your suitcase. When you go to an airport, you're worried you might lose your suitcase. What do? You attach an active RFID tag to it, like the YAR tag. Everybody okay with this? Like the Samsung Smart Tag. You attach it to it. Then from your smartphone, for quite a distance, you can track it. Everybody okay with it? Because the tag has a battery built into it. Boys, girls, everyone okay with this? Sounds good? Okay. Right. Then guys, let's have a look at passive RFID tags. This is where we're going to spend some time over here. Passive RFID tags are basically a sticker. Everyone okay with this? What did I tell you all? Passive RFID tags are basically a sticker. Let me see if I have an image over here. It is exactly this. It is a very, very thin sticker. Inside the sticker, you have an antenna and you also have a microchip. Now, all of you girls, all of you look here below. How does a passive RFID tag get its power from? A passive RFID tag gets its power from the reader. You get it? There are two things now. You have your reader, you have your sticker. What do we call the sticker? The tag. Okay, so you have your passive RFID tag and you have your reader. This reader is continuously sending out what waves? Radio waves now. It's continuously sending out radio waves. These radio waves will be detected by the antenna on the sticker. Is it clear? The moment this antenna receives those signals, it can convert it into current, a very small amount of current. And then that current can power the microchip. Is it clear? That current, the antenna receives signals now. That signal can be used to power the microchip. Then whatever data is inside the microchip will be wirelessly emitted. Whatever data is there inside your microchip will be wirelessly emitted by this antenna. Who is going to read this data? Who is going to read this data? Your reader. Everybody okay with this? Your reader will read this data back. So where do we use this? Everybody, I'm going to show you all a video. You all know what are warehouses? Shahad, all of you are with me. You all know what are warehouses, right? Think about Daraz. Daraz has a warehouse. Think about Maliban. Think about Manchi. Okay, I don't think they use it, but just think about it, okay? They have a warehouse of all their goods, isn't it? And for example, guys, they receive an order from Keels for what do you call 1,000 pieces, 5,000 pieces, 10,000 pieces of a particular biscuit, for example. They have no time to open boxes and count how many packets are there. You get it? Because they are dealing with large volumes. Opening boxes, counting whether there are 5,000 pieces inside it is a waste of time. So do you know what they do? For every product, they put an RFID sticker. What sticker? Not active, passive. For every product, they put a passive RFID tag on it. Everybody okay with this? Now, when the box comes into the warehouse, what do? They just scan the box. In 1 second or 2 seconds, it will tell you what? How many products are inside the box. You guys understood what I just told you all? So you don't need to open the box and count the products one by one. You just scan the box. It will tell you how many pieces are inside the box. It will basically count the number of stickers inside. Isn't that very efficient for you? Very efficient, right? Can you guys check this video out? Check this video out. Where is it? Guys online, check it out. Oh, 1 second. It's a long video. I'm going to only show you all what is most important. Right, everyone, when it comes to QR codes, can everyone come down to QR code? What I was telling is, when it comes to QR codes, users can create their own QR codes, and QR codes can hold a lot more data than a traditional or linear barcode can hold. Are we okay with this? What we all need to know is, what are the parts of a QR code? Okay, what are the parts of a QR code? You all need to learn that. There are 2 past paper questions that ask you all that. Okay, so can we get started, guys? Okay, everybody, can we get down? Can you get down over here? Can you all see the different parts? Now, obviously, they will not ask you to label a QR code because it looks all the same to you all. But they might ask you what are the parts. You'll have to write it. Okay. So can you guys come down to position pattern and can you all highlight the key function of it? Everyone, position patterns, key function, can you all highlight? Okay. It is located at 3 corners. That's not the function. No, that's where it is located. Can you all see the next part? It allows a scanner to accurately recognize the code. That's the key function of your position pattern. Can you all highlight that? Allows a scanner to accurately recognize the code. Okay. Also, what does it do? Indicates the direction in which the code is printed. Everyone okay with this? This is your position pattern. Everyone, this is your position pattern. Helps in accurately reading your code and helps in indicating the direction of your code. What is top and what is bottom. Okay. Then can you guys come down to the next one, which is your alignment pattern. What happens over there? It makes the QR code readable or scannable from all angles and directions. Scannable from all angles and directions. Okay. Position pattern. Now we are looking at alignment pattern. The third one, timing pattern. What does it do? Determines how large your data matrix is. Okay, the reading area. Tells the scanner or helps the scanner determine how large the data matrix is. That's your timing pattern. Then you have your format pattern. Can you highlight the key component of format? Okay, you can either say makes it easier to scan the code, or you can say contains information about error tolerance. Okay, or you can say makes it easier to scan the code. You choose. Okay, highlight these key components. Format pattern makes it easier to scan the code. Then guys, you have something called your quiet zone. This is the area outside your QR code. Everyone, can we highlight that? Empty margin or space surrounding all 4 sides. Okay, your quiet zone is basically the area outside your QR code. I'll give you all 30 seconds, guys. Can you go from top to bottom again? Top to bottom, please. Top to bottom, please. Okay. Then guys, girls, a QR code which is going to be continuously updated, we call it a dynamic QR code. I'll give you an example. For example, I'm giving you a QR code to a website. That QR code is always going to be the same. For example, we have put Platinum's banners outside now, and we have said for more details about full-time, scan this code. When you scan that code, every single time you'll be taken to Platinum's website. Everybody okay with this? To scan this code, for more details, scan this code. Every time you scan it, you get to Platinum's website. Everybody okay with this? Then I'll give you guys another example. Say, for example, we give your parents a report card and we say, to know the latest performance of your son or your child, scan this QR code. Now, every time your parents scan this QR code, they're going to see your latest performance. They're going to see your latest marks, your latest attendance details, your latest average. Now, this information is continuously changing. Agree? Everybody agree with this? So this is known as a dynamic QR code because the information inside it is going to keep changing. But on Platinum's billboard, when we say scan this to view our website, that is a static QR code. It's always going to take you to the same page. Does that make sense, everybody? So static means it's a QR code where the destination and information is always the same. Dynamic means what? The destination will keep changing. Are we all okay with this, everybody? Can you all read it now? The code will remain the same, but the information that is shown to the user will change every time. Are we all good with this? Static versus dynamic QR codes. Then guys, without going to technological convergence, everyone, did you all go through that? Dynamic versus static, everybody okay with that? Okay. So technological convergence, I'm going to keep it for our next class. Can we do a few questions now? Everybody, can we all come down to page number? Everybody, page number what's number 21. Can everyone come down to page number 21? Question 2. The botanic garden sells plants in its own shop. The shop attaches a passive RFID tag. This is a sticker to each plant. Describe how passive RFID tags work. How do they work? First, tell me, what do they contain? Every passive RFID tag will have an antenna and a microchip. Shall we start off with that? Then we'll keep adding to it. Okay. Every passive, you can say the passive RFID tag, the passive RFID tag would contain an antenna and a microchip with data built into it, or with data stored in it. Agree now with me? The microchip would have data stored inside it, and a microchip with data stored on it. Okay. How is the microchip read now? From the reader's radio waves, signals or radio waves. Okay. So you can say the microchip is powered by, oh, let's go like this. The data in the microchip is read. The data in the microchip is read by receiving radio waves from the reader, which will be collected by the antenna and used to power the microchip. The data in the microchip is read by receiving radio waves from the reader, which are received by the antenna and used to power, which are received by the antenna and used to power the microchip. Once the microchip is powered, it will emit signals of its data that can be detected by the reader. Okay. Once the microchip is powered, it would emit wireless signals that can be detected by the reader. So this is how passive RFID tags work. Okay. Talk to yourself when you're writing it. Okay, give me 1 second. I'll just quickly take attendance. Guys online, hold on, please. Okay. Okay, everybody. If you guys can have a look at question 3, then one use of RFID tags is to help reduce theft. How can you use RFID tags to reduce theft? For example, at the exit, you can have an RFID reader, right? So when the reader comes in contact with a tag, the reader can start beeping. So then you know, for example, somebody is walking out with a plant. Everybody okay with this? Normally, when a customer comes and bills, you might remove that sticker. So when they walk through the exit, the reader will not be able to detect anything. But when somebody without purchasing tries to walk out, what will happen? The reader at the exit will detect the tag and it'll start beeping, for example. You can program it to beep. So then you know somebody is walking out without billing. Okay. By the way, guys, clothing stores in Sri Lanka, like No Limit, Fashion Bug and all, they are not using RFID tags. What are they using? They're using a magnetic system. Okay, they are not using RFID tags. They're using some magnetic system there. They remove that device using a magnet. Okay, they are not using RFID tags. Don't confuse it there. So give one other way that the shop could make use of the RFID tags on the plants. One is for theft. Another reason they can use it for? Louder? To identify the plant. You scan the tag, the reader will tell you details about the plants. So number one is to identify the plant. Another reason can be if they want. If they have been watered, to keep track of medicine details, watering details, perfect. Another reason can be for stock keeping purposes. I just hold the reader, it will tell me how many plants are there. Isn't it? For stock keeping purposes, for inventory purposes. Okay. Anything else you like to tell? To store details about the plant. Somebody already said that, no? To store details. So when you scan, it will give you details. How old the plant is, what has it been fed on, you know, things like that. Okay. For inventory purposes. For inventory purposes. Are we all okay with this? Guys, girls, what do you all think about this one? A botanic garden uses QR codes to label trees so that visitors can view information about them using a QR code scanner. The patterns of squares holds data that displays as text when read by a scanner. All QR codes include additional information that enables the scanner to read them. State 3 items of additional information included in a QR code. I gave you all about 6, right? I gave you all. So what do you have? The area outside your QR code is known as your quiet zone. You have your quiet zone. What else do you have? Alignment pattern. What else do you have? Sorry. You have your format pattern. Anything else? Position pattern. Timing pattern. Timing pattern. Okay.